Hello and welcome to the St. Baldrick's Impact Series. I'm Kathleen Reddy, and today we're going to talk with Greg Tananbaum, Director of the Open Research Funders Group. It's a partnership of leading philanthropies committed to the open sharing of research outcomes. Members' interests span life, physical, and social sciences, as well as the humanities, and collectively fund more than $12 billion in research annually. Additionally, Greg serves as the Secretariat for the National Academies of Sciences, Engineering, and Medicine's Roundtable on aligning incentives for open scholarship. Welcome, Greg.
Thank you. It's a pleasure to be here. I appreciate the invitation.
We're so glad you are. Let's jump right in. Greg, tell us, what is open science and how does it benefit society?
Yeah, thank you. As you mentioned, I run the Open Research Funders Group, which is a network of private philanthropies that are aspiring to broaden both access to and participation in the research conversation. And practically speaking, we help our members and other funders implement and oversee and advance guidance to their grantees, embedding really what is the fundamental principle that research outputs resulting from grant funding should be widely shared. We also work as serve as the funder's voice in strategic cross-sector discussions about how to effectively catalyze and harmonize and scale open science and open scholarship activities, which means we work with colleges and universities and professional societies and associations and government agencies and industry to align incentives and stand up critical infrastructure and make open science and open scholarship easier for researchers to actually do. Why do we do that? What does open science mean and how does it benefit society? Well, I think philanthropies typically aspire to really lofty goals, right? So solving what may seem to be intractable problems like climate change, or creating a more just and equitable society, or curing diseases like childhood cancer, or deepening our understanding of our place in the universe. And so the scale of those ambitions, really not just the scale of those ambitions, but the magnitude of the challenges that we face as a society and as a species demands that we identify better, more efficient ways to broaden the circle of research and to include a diversity of voices and approaches in our work, and to accelerate the pace of discovery, and to make research findings more replicable and more accessible, and to improve public confidence in science. And we believe that openness is really an enabler of those goals.
So it's a huge task, and you're working with lots of different types of entities, which I know you'll talk more about. But let me ask you this. So a common measure of success for any researcher is whether or not that researcher has seen their results published. Why is that? And then why should maybe that change?
Great question. It's certainly true that one metric of academic success has traditionally been publishing in brand name or high impact journals. And one reason this became a shorthand for success is quite frankly that it's easy, right? It's easy to evaluate. If a researcher publishes in a prestigious journal like Cell or Science or Nature, that can be seen as a proxy for high quality research. If the journal has a high impact factor, which is quite literally a number that is higher than the number that another journal might have, that's really easy to understand, right? And I think there's a problem with that, of course, though, which is that the journal is a wrapper. It publishes lots and lots of papers, some of which are well cited and transformational in the field, many of which are not. So in some ways, we've created a flawed incentive system in which we're rewarding authors for publishing in certain journals, but we don't really do the extra legwork to confirm that their specific research was meaningful or impactful or even replicable. Another problem is that scholarship comes in all shapes and sizes, right? So it's not just about articles. There are data sets and software and protocols and monographs and books and multimedia and on and on and on. And so an incentive system that's based primarily on journal publications is really missing lots and lots of potentially valuable work. I also, I think we should be we should be thinking about the dissemination of a research output as a point in a larger continuum, right, rather than just a terminus. So to the extent that a work can be widely accessed and tested and replicated and combined with other research and built upon, that really matters. Research that is siloed is ultimately research that's not making its widest and deepest possible impact. So I do think expanding our notion of what impact looks like, what success looks like, what a finished research product looks like, we do need to do some work to broaden our horizons collectively.
So in our corner of the world, we're focused here at the St. Baldrick's Foundation on childhood cancer research. How does open science in medical research benefit patients? And can you talk about any of the advances that have come or been made possible that wouldn't have been possible without open science?
Yeah, I love this question because it's not open science, open scholarship. They're not theoretical constructs, right? It's not just something that we're advocating for because we believe it's the right thing to do, that it's the moral thing to do. Although I do feel that there are real, practical, defined, tangible benefits that we can look at. Just thinking of some of the open science success stories, and I'll talk about biomedicine because obviously that's where St. Baldrick's dedicates its time and energies largely. So the Human Genome Project is an open science project, right? So not only has it provided us with really unprecedented understanding of the building blocks of life itself, but it's also allowed us to determine predisposition to any number of conditions, including cancer, including cystic fibrosis. It's opened the doors to new treatments for cancer, for Alzheimer's, for many other diseases. And as a side note, it also, the Human Genome Project is a great demonstration of open science's compatibility with economic development as well, right? So it's generated almost $1 trillion in economic impact from the late 1980s through the first decade of this century, and also generated nearly 4 million jobs. That's obviously a great example. There are lots of others as well. So there's the Open Source Malaria Consortium, which hosts an open repository in which scientists really from around the world freely share their research on anti-malaria drugs. That's had a real tangible benefit in accelerating discovery of new drug candidates that can go into preclinical development. COVID is obviously a great example, right? So during the height of COVID, data and protocols and preprints and articles were shared really at a speed and at a volume that was unprecedented for scientific communication. And that helped to identify the most promising treatment avenues, as well as identify dead ends that really we shouldn't be pursuing at the expense of more promising alternatives. Another example, just returning to genetics for a second. So just recently, an international team of researchers shared anonymized genetic data from just about 100,000 patients from around the world. And the effect of this was to identify 5 new genes that are associated with Alzheimer's and to find indicators that tau plays a much earlier role in the development of the disease than was earlier thought. That could not have happened without that sharing of data at scale. I'll also just mention, we actually, through the Open Research Funders Group, we maintain a database of open science success stories like this. It's available at our website, projectopen.io. So I invite folks to go there and explore in more detail stories that may be relevant to their field.
Well, hopefully this open science collaboration will help us understand why there's a greater incidence of these diseases as well, because that will allow us to attack things at the root and not wait for patients to have a problem before we start addressing it. So the potential here is so evident. So thank you for explaining that. Greg, you've indicated through some of your statements today that you're working across multiple sectors: academic, philanthropic, government, corporate. These are vastly different enterprises. Every stakeholder and all of them want to see results, but they operate differently. They have different expectations, and some have profit motives, some don't. There's all different things. So how do you cut through all of those complexities and find common ground and figure out how to make progress and get everybody pulled together?
Yeah, it's a great question. And across those sectors that you mentioned, excuse me, there's actually a pretty good consensus around open science and open scholarship concepts like transparency, like replicability, like reproducibility. And there's also some clear and established practices like fair data sharing, findable, accessible, interoperable, and reusable, like open access for papers, like pre-registration of research studies. Those are practices that support those concepts that I just mentioned. But really where the work needs to happen is on making open easier for individuals and for the organizations that support them. And so that's a lot of what we focus on. And some of that, not all of it, but some of it also relates to aligning incentives. And for us, central to these efforts is, you mentioned in my bio, I helped coordinate the National Academies Roundtable on aligning incentives. This is a project that started in 2019, and the goal was to bring together leaders from across these sectors to work on harmonizing and catalyzing and scaling open science and open scholarship activities. The Roundtable operates under a theory of change that we've honed across a number of years and really hundreds of consultations with scholars and students and policymakers and administrators and technologists and publishers and more. And the theory there, our theory of change is really that we need to develop mutually reinforcing vectors in support of open scholarship. And really what that means is creating an environment in which the guidance and the rewards and the support that researchers receive from their department chairs and from their university leadership and from their funders and from their professional societies and others really consistently points towards open. So hiring and tenure and promotion and funding conditions and disciplinary awards and honors really can consistently embed expectations of openness. That doesn't mean that every funder and every university department across every discipline is going to have the same language or the same policy, but we can get directional alignment across those vectors. That feels really, really attainable. And so practically speaking, how we're doing that, the Roundtable actually has spawned a number of different offshoots. There's the Higher Education Leadership Initiative for Open Scholarship, which is a group of 87 and counting colleges and universities that are working on this from a higher ed perspective. There's a coalition, a cohort of 10 diverse professional societies called the Alliance for Open Scholarship, which is looking at generating field-specific norms and good practices. There's an ad hoc group of 60 philanthropies that are working on incentive alignment and making open easier within the philanthropic sector. So there's a lot of work that's happening, and what we're trying to do in the Roundtable is stitch across these, sort of serve as the connective tissue, again, to harmonize, catalyze, and scale.
So you're describing multiple efforts to kind of overcome any inhibitions or obstacles to open science. But I would imagine there might be other legal, economic, technology, or other human factors that might be inhibiting it. What else? What hasn't been tackled yet in the space?
Yeah, it's a good question. So there are considerations like intellectual property, like commercialization, like data privacy, like there are metadata and persistent identifiers, the sort of plumbing and wiring, the infrastructure that goes into this. Those are all tractable, but in aggregate, they seem it feels like a heavy lift. What we try to do is we try to bring enough sectors and enough key actors within those sectors together to say, look, collectively, we can solve this. It requires you to do this thing and you to do this thing and you to do this thing. Let's work on that so it doesn't feel quite so daunting.
Mm-hmm. At St. Baldrick's, we say research is hope, and we believe that strongly. What efforts are underway in pediatric cancer a la open science to create more hope for families of kids with cancer?
Sure. And I'll preface by saying I'm by no means a domain expert, but I do know within our universe there's some good examples. So one is Alex's Lemonade Stand. So they have for quite some time asked grantees to share a range of research outputs, model organisms and cell lines and plasmids and protocols and software and papers and data in a timely manner and on public repositories. Resource sharing plans are evaluated as part of the peer review process. There are scored criterion during the peer review process for grant applications. They've also created the Alex's Lemonade Stand Childhood Cancer Research Resources Portal to bring transparency to childhood cancer research resources available within the community. And policies like that really do matter for families of children with cancer, and they matter in a couple different ways. So first, they create the conditions for better science, right? So research that is open is more easily tested. It's more easily built upon. I mentioned that earlier. Openness also enables faster translation of research discoveries into cures for children with cancer. I'd also mention that having access to the scientific literature matters tangibly for families, right? It allows them to understand the state of the art in clinical trials and disease progression. It informs conversations with doctors about treatment options. So it isn't just about open science, isn't just about, making sure that these, esoteric postulations in dusty scientific journals go into the hands of slightly more people who won't understand it or won't be able to do anything with it, right? It's really about spreading access to knowledge in an area where knowledge can mean hope.
Mm-hmm. Well said. Knowledge is hope. Research is hope. Greg, thank you so much for sharing the vision for and the potential of open science and how fostering it we can fast track advances for patients. We wish you great continued success in your efforts, and thank you for your time today. To our audience, thank you for remembering Research is Hope and for doing your part by sharing this episode on your social networks and by making your own contribution to life-saving childhood cancer research at stbaldricks.org.